Hello, my name is Josh Rangold, and this is my Physics 2212 Lab 3 circuit. The purpose of this lab was to predict the behavior of circuits and check based on CCK simulations. It also uses voltmeters and ammeters to measure current and voltage at certain positions in the circuits and compare theoretical and experimental value. The primary physics principles used in this lab are the node rule, shown at the top, the loop rule, shown in the middle, and the time constant calculation for the RC, shown at the bottom. The main results of this lab were that the current in the circuit with the two resistors was approximately 0.02 amps. Resistance and time to charge a capacitor are directly related, and the time constant RC was approximately 2.24 seconds. Some justifications and assumptions made in this lab were that conservation of charge and conservation of energy allow us to use the node and loop rules, and that also the circuit remains closed, no external forces or charges affected, and the components are idealized because of the simulation. To initialize this experiment, the system was defined as the measuring instruments, namely the ammeter and the voltmeter. The surroundings were the rest of the circuit, and the initial conditions were that the measuring instruments were placed at a strategic location in the circuit and that the batteries are charged. Part 1 of this experiment, methodology 1, was to make a prediction of the currents I1 and I2, set up a circuit with two ammeters, and test the predictions, then reverse the ammeters and read the new measurements. Methodology 2 was to set up a new circuit with one ammeter, use a voltmeter to measure the voltage across each set of 2 points in the circuit, and then graph the potential versus position around the circuit. The third and final methodology for part 1 was to modify the circuit again so that the ammeter is in parallel with the 100 ohm resistor, and then measure current through both ammeters. The data from part 1 of the experiment was collected and shown here. The predicted I1 and I2 values were 0.02 amps, and the actual experimental values were also 0.02 amps. When the ammeters were reversed, they measured at negative 0.02 amps, and the parallel ammeters were measured at 0.06 amps. The graph for the voltage versus position in the circuit is shown on the right. Part 2 of the experiment, the methodology was to create a new circuit using a 9-volt battery, a 200 millifarad capacitor, and two bulbs. Measure the time it takes for the bulbs to light, charge the capacitor and measure it, and then remove the battery and measure potential difference on the capacitor every second. The data collected for part 2 of the experiment is shown here. The light shone bright and then dimmed when the capacitor was charged and when it was discharged. Current showed an exponential decay relation. The 20 ohm bulb took about 3 seconds to dim, the 30 ohm bulb took about 5 seconds to dim, and the slope is equal to negative 1 over RC, shown on the right, and therefore RC is about 2.24 seconds. Some potential error in this lab was the rounding on the ammeter and the voltmeter, as well as human error with timing the charge and discharge of the capacitor. Additionally, this lab idealized all components of the circuit because it was done through a simulation. What if a real ammeter was used? In real life, all components of the circuit, such as the wires and ammeters, would have non-zero resistance, and therefore this would decrease the measured current in the experiment. What if a real battery was used? Similarly to the last discussion question, in real life, all components of the circuit would still have non-zero resistance, and therefore this would slow the rate at which the battery can charge the capacitor.